Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at L-Tri-C. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. Today's video will review half-life calculations. They can get very complicated. The formula, really, the mathematical formula for half-life calculations is pretty complex, but for introductory chemistry courses, you'll only be dealing with a few half-lives, say 1 to 4 half-lives for any kind of example you'll use. So what I'm going to review here is a way you can go about doing those problems without having to use the complicated mathematical formula. Now, the half-life of a radioisotope is the amount of time it takes for 1/2 of a sample to decay. So as I show here in these chart that I have here, if you start with 40 milligrams of a radioactive iodine, we're using radioactive iodine today. If you start with 40 milligrams, after one half-life, and half-life would be normally in hours, so after one half-life, you have only 20 milligrams. Half of your 40 milligrams is now gone. It's been converted into another element, and you're left with 20 milligrams. If another half-life occurs, then that 20 is cut in half again to 10, and if you have one more, you're down to 5 milligrams. So in this example, to go from 40 milligrams down to 5 milligrams is 3 half-lives. One here, and one here, for a total of 3 half-lives to get down to 5 milligrams. So you're doing that half every time you have a time period of a half-life. So let's take a look at a problem. We're going to use, in this case, this is technetium-99 as your radioactive material. It's an ideal radioisotope for scanning organs because it has a half-life of 6 hours. So we know that one half-life takes 6 hours. So every 6 hours, half of your technetium-99 is gone. So now let's suppose that we start with 80 milligrams. And then you want to know how many is remaining, how much of that technetium-99 is remaining after 18 hours and then after 24. So we're going to start with A here at 18 hours for the first part. Well, we know that for every 6 hours, we have one half-life. So after 6 hours, there's half remaining. So after 18 hours, if you do this math, you'll see we come up with 3 half-lives. So this technetium-99 is going to undergo 3 half-lives. So then you start with, we had 80 milligrams. So we're going to do times 1/2 will give you 40 milligrams. That's 1 half-life. Then we're going to do it again, another half. We're down to 20 milligrams. That's 2 half-lives. And we got to do one more, down to 10 milligrams, which is 3 half-lives. So our answer for A is 10 milligrams for 3 half-lives. Now, if we do part B, we're going to do the same thing again. This time we're going to do 24 hours. That's going to end up being 4 half-lives. So we're just going to do one more here, get down to 5 milligrams for 4 half-lives. So you just take a half and do it the number of times that you have half-lives. This next one is another half-life problem, only working a little bit in reverse. So this problem says, suppose you have a piece of wood found in a tomb that had 1/8 of its original carbon-14 activity. about how many years ago was the wood part of a living tree if the half-life is 5,730 years. So here we have to look at, we want to get 1/8 of the original material is how we're going to figure out how many half-lives. So now I put down here some fractions for you. Assuming you start at 1, after 1 half-life, you would have half left. After 2 half-lives, you would have a quarter of the material. Take another half, now you're down to 1/8. That's 3 half-lives. And in this case, that's what we're looking at here. We have 1/8 of the material left. But if it had been 1/16, that would have been 4 half-lives. And again, if it was 1/32, 5 half-lives, etc. And as I said, normally in introductory chemistry, you won't go very much farther than 3 or 4 half-lives. So we know in this problem, the material underwent 3 half-lives. So we know now that the wood underwent 3 half-lives, and each half-life is 5,730 years. And so the answer for this, I didn't work out the numbers, but it's somewhere around 17,000 or so years. Sorry, I apologize for not getting the number, but that's how you would go about doing your half-life calculations. And like I said, I showed a couple of ways to do it simply when you have just a small number of half-lives. Thank you.